Hi everyone, my name is Emerson Eduardo Rodrigues. On this video I would like to talk about an LT, the LT study case that we have made for the operator Claro, okay? So I have 15 years working as RF engineer, experiencing the whole experience in the telecommunication area as engineer. Since 95, working together in the as technician and the engineer. All right. So I have run at several countries in several overseas, several projects overseas. All right. So I have, I believe, a strong background to optimize the all network. Okay, 2G, 3G, and 4G and 5G as well. Alright, so let's talk about the study case for LT in operator Claro. Okay, Claro, Colombia. That's America Móvil in some places in the Central America, right? So first step, we're gonna talk for spectrum usage for Claro. Okay. The purpose of the Claro spectrum layout was AWS before it was complex, 20 megahertz, okay, in the urban LTE capacity, okay. There are three layers, right? Using UMTS 850 megahertz, 5 plus 5 megahertz, all right. And the 8500 megahertz, 2.5 for GSM, right? So let's pay attention to the time, right? Because I have the line. The data overlay that we have made between APT 700 times megahertz minus LT coverage. So then we can make for smartphone capacity. In GU 1900, GU shared GSM UMTS, and 17.5 megahertz for GSM, more 5 plus 5 UMTS for 7.5 for GSM, right? And the smartphone coverage, it was transferred for 800 for UMTS, and the voice capacity was GU 1900, right? So indoor coverage layer in the indoor, the planification for this, because we need to have this study, the whole study complex, right? So for 850 in the 2.5 megahertz. Destinated for smartphone coverage. No, sorry. It was voice coverage. It's, yeah, sure, because it's strange. For GSM, the voice coverage, and for voice capacity, you use multi-layers of that. And the data overlay, where we have some issues with the CS fallback, that I will explain beyond, right? Okay, so let's talk about LT in a SRAM perspective. Single RAM broad hardware pipe solution. Okay, single BBU and cloud BBU and cloud BB evolution. Before it was MPT and the concurrent MPT that was for SRAM 8.0. That it was a old evolution. And then concurrent BPT, and then it's went to develop it, right? So it was developed, right? So there are general hardware, UBPP, UBBP GUI, UMPT GUI, and the single BBU, not just a co-BBU, right? So from MPT concurrent to BPT concurrent. So in the BBU stack, in the last version, there were the BBU stack and the centralized maintenance. So the cloud BPT and pull for there is a BBU pooling too, and cloud BB as well. That's a near future that we are using nowadays, right? In 2017, we are using the cloud BP. So they're designated in the cloud BP, 30% capacity improving and the 30% OPEX saving, from OPEX saving, and KO much more enhanced, right? That it was involved to cloud BB step by step. That's increase BBU capability double every year. The BBU capacity, the radio systems are going to be double every single year. And BBU architecture evolution matching BBU growth, right? And the single BBU architecture for SRAM, right? So the single run GUIL and GUIL, there are GMTU and U and WMPT together in the same layer WBBP and the layer GL4L, LMPT and LBPP, right? So on the first layer there are single run in the OSS, okay, separated U1 interface dedicated for the third layer and the third layer dedicated hardware for each red, right? So that's the main difference. So nowadays we have single UM OSS, single U1 interface and a common hardware for each red. This was changed. On the single run common BBU benefits single operation from one team to one knowledge, okay? Single run with three brains in 2013 approximately to now, right? GSM UMTS LT and then GSM UMTS LT it was improved for common hardware test instance minus 80%. The single run rate related, okay, in the common hardware test instance. On the MML commands for ME2000, things like that, right? Minus 40% in the MML commands. It was a great job, right? And integration parameters, time is per thousand, minus 40%, right? UMPT evolution and specification, UMPT evolution was a before semi hardware for UMTS and LTE and hardware ready for GUI content concurrent evolution, and nowadays GUI concurrent and dynamically signaling sharing. You know what I mean? You need to you can share the signaling, right? So the UMPT specification and capacity was improved for G72 TRX in the 72 TRX, okay, in the U1500 CNBAPS, right? On the L we have 120 caps, right? And the GYL we have a typical concurrent 18 TRX plus 1000 CNBAPS plus 30 caps. Alright? So, okay, that's fine. Next step. Blade BBU, Blade RRU designated for multi-band and multi-rate scalability, right? The first scenario, band X, sector 1. Scenario 2, band X plus Y plus or epsilon or plus or sector 1 plus 2. On sector 3, band X plus epsilon plus C plus zeta C, right? Or sector 1 plus 2 plus 3. The main difference consists in a unique, seamless assembly in the on-box, multi-band, multi-rate, and the multi-sector scalability. Smallest and the fastest, 12L and 4 kg, 4 kilos. In industry, most lightweight is the most lightweight, only 4 kilos. Okay, the Blade RRU, the Blade radio interface. This is only 14 kilos is much easier to install to you plot in the field, and for the teams it's becoming very easier because you know they don't get so tired to assemble these and to mount it on the tower. It's very good because we have a teams. I have a teams working in several countries and other projects. So they are working nowadays assembling the towers. These RRU. The oldest one was bigger, so it's heavy, very heavy. So nowadays it's smaller and only 14 kilos, so it's easier. 3 models installed under 5 minutes. Only 5 minutes is very easy to install, you know. So the best in the class RF performance up to 10 watts, L power density up to 60 megahertz IBW, 30% less power consumption. So okay, per TRX, your cost benefits going to be increased as well. Per TRX consumption. Alright, so the blade RRU flexible installation, $6 before, and nowadays $2, right? 66% box safety per site, 50% workload safety for cable, and 50% wind resistance reduction. Okay, so the blade RRU flexible expansion is for 12L to 24L and then 36L. Band X plus epsilon or sector 122 or 4x4 MIMO. Multiple input, multiple output, you know, MIMO. Alright, band X plus epsilon plus Z or sector 123 plus 123, right? Like that. It's for 24 and 36L. Okay, so the electric duplexer on chip for all digital functions decreased 30% of power consumption because they're only on chip for all digital functions. The electric duplexers 50% highest power efficiency. Super slim thin decasting for ultra high efficiency. Heat sink is 2L, only 4 kilos. So industrial highest integration. Channel fresh air compensation. On box assembly, right? So that's fine. The best in the class RF performance. DPD plus duality 40%. And then it was increased. Let's go ahead just to talking about the capacity gain. It's about 60% in the capacity gain. With 2RX cell average throughput, when you see cell average throughput, it's going to be increased in kilobits 15, you know, in the less than, for example, 4RX, alright? In the UL 4 antenna receive diversity with 4 antennas per sector for receiving, right? So the uplink shared channel IRC, the scenario in the urban area is small ISD inter-site distance. So this is study we must make. Okay, we have done over there. There is a formula here and all things. And the PU SCH IRC, the gain in the 2RX was 3.7 dB, and in the 4RX it was greater, much better. 5.3 and the 5.7 dB, right? There's a formula here. If you need to know, I can send for you for your email, right? So the uplink sharing channel push PUSCH it was 90.55% increase in uplink cell average throughput. One time if I run MMC compared and MMC MRC. So support of adaptive switch between MRC and IRC. There are support adaptive switch. It's very supportive, right? So that's fine. Okay. Next video. Just finish this part of video. We will talk about the uplink control channel IRC. they're going on 1 dB in QRX. Format 2 times 0.5 dB gain QRX, and the format 1 time 2 dB. Only if you use one, it's 2 dB. And format 2 times 0.7 dB in gain for RX. Okay, it's input RC, and patch IRC you can gain 2 RX. 2 receptions 8 dB, and for 4 RX you can get 8.8 dB, right? Uplink control channel push and patch you can, and it's about 24% increase in uplink control channel coverage and improve network access rate. Your KPI is going to be very good because it's improving very well the network access success rate, and the support of adaptive switch between MRC and IRC. No edge of uplink on intra-node B and co-MP improve 10% cell edge in the uplink throughput. Alright, so there's a in the cell average throughput, the gain was about 7%. Without SMP we have a loss, you know. And with the COMP, we have a 10% increase in the cell edge throughput. Okay, that's fine. This video just to talk about these gains using equipment, the LT feature in the highway equipment. Okay, thank you so much. Subscribe my channel. Leave your comments over here. So as soon as I can give a quickly feedback for you. Thank you so much. Cheers. Bye.